Okay, now let's go and set up our photos that we've dragged into this particular block file. Now you'll probably notice that these images down here are slightly different to the ones that were in the first section of this tutorial. For reasons I won't go into, I've had to change the images, but for all intents and purposes the camera information and everything else is exactly the same. To set the photos up, we click on the information icon. You'll see that our sensor information is saved from the previous information that we entered in. So let's get on to the interior orientation. Now to do this, we click on the Edit All Images icon, and you'll see that the image name and the sensor name are shown here, and there's also an orientation column. Now to give you an idea about the orientation, this is a diagram of a calibration certificate for this camera, or for any number of aerial cameras. The lens number is down the right hand side as we showed you in the first tutorial, and the recording instruments information, the information tab, is on the left hand side. If the plane flies east to west, north is up, and this orientation holds true. So the direction of X is to the right. So if the plane flies east to west, right X. In this case, right X is shown in the orientation tab. These images were flown from east to west, and so right X is the correct orientation. If the plane flies from west to east, rotate this around 180 degrees, so your lens number will be up here, and you have to use left X because this X arrow will then be pointing to the left. If it flies north-south, you have to use a different orientation, and if it flies south-north, the same. If it flies from west to east, the kappa value in our table, which is here, has to be set to 180 as opposed to 0 as it is here. If the plane flies from north to south, the value is 90. If it flies from south to north, it is minus 90. Okay, so for this job, east to west flying, this orientation plus X to the right, so right plus X. Okay, these columns here are where we enter in the location of the photograph in space, its X and Y coordinates. This column is for the flying height. Okay, we also have to set up some basic parameters for the job, and that is the standard deviations, which are in these columns here, and the stadia information. So firstly we'll do this. We've highlighted all the stadias, all the standard deviations, we've highlighted all the images. Right click in this field, click on formula, enter the number 2 for standard deviations and apply that, closing out, and it pads all these fields with 2s. We'll do the same thing with the stadia. Right click, formula, we set up the word initial in these fields to show our initial starting point, and that's been populated. Now I've written down the location information for these photos. I've taken it from our ArcGIS Air Photo Centers diagram information. These are the 3 photos that I've located in space. This is the flying height information, and we can take the XY coordinates by putting our cursor over the point and reading it off at the bottom of the screen. You'll see at the bottom of the screen there the meters showing just down here. That's the location for this principal point, and this one, and this one. So I'll just enter that information into these columns. For photo 115, it is 318, 536. For the next photo it's 314, 001, and for the final photo it's 309, 465. This is the easting information. The northing information, 670, 5284, 670, 5139 and 6705047. And the flying height, now this is not the height of the ground, this is the height of the film plane at the time of taking the photo, was 8,453, 8,473 and 8,471. So now we've entered all the information that we need in these fields. Now we have to tell the computer where the actual photo sits in the camera by its calibration of its fiducial marks. You'll be aware that if I click on this, it goes to the corner of the air photo, and at the corner of the air photo we have these fiducial location marks. This is what's measured in the calibration of the camera. Put this selection box over the top of the fiducial mark, select the fiducial location icon and find the exact center of this field and click. It will then jump automatically to the lower left corner. We'll have to drag this box in here when you get the crosshairs. Do the same thing with this one, so we get the magnified view here, and we'll collect this point next in sequence. And now that we've collected two, it knows roughly where the third one's likely to be, so it jumps close to it. We'll collect the third point, and now it's much closer still. We'll collect the fourth point. Right, 1.5 pixels is an acceptable resolution. We'll go to our next photo. Once again, the image X and Y values are blank. We'll collect our first fiducial point. Okay, we'll drag this one across so we can see this one. Collect our second one. Select this icon. Okay, just to make sure that you can see all these properly, I'll drag it up a little bit. Next one is selected, ready to go. Select that one and select the final one. 2 pixels is fine. And our last image, we'll just collect our fiducials. And 2, 3, and 4. 1.3 pixels, fine. Okay. So we've now collected our fiducial points, so the camera, the system knows where the film is in the camera, the calibration of the camera, the focal length. It knows the position of these photos in space, and so at this point I'll go on to the collection of the control points to set up the exact positions in space for the final orientation, or the exterior orientation as it's known. But I'll stop this tutorial there and I'll come back in tutorial 3 to do the rest of the work.